frequency above 550 kHz. Normally, for example, in AM demodulated circuits, they are made of germanium because they have to rectify starting from 0.2 volts. If you use a silicon diode, it will rectify only from 0.7. Here, there may be certain information between 0.2 and 0.7. Therefore, only germanium have to be used. Like that, these diodes are useful for high frequency rectification only. High frequency rectification in communication equipments. And then coming to okay, fine. After this high frequency diode, I want to say one example which was useful for rectifying a low frequency also, which was manufactured for high current capacity. That diode was called as BY127. It was a very good diode. B means silicon. Silicon diode, high current, 1 ampere current rating, high voltage, that is 300 volts can be rectified using this. Whereas 4002, 4007, 4002 can be only for 50 volt. Like that, B127 is a very good thing. It was manufactured by Bharat Electronics Limited in the year 1970. For example, I am telling this. And then moving on from high frequency diode, let us go to a regulated diode. What is a regulated diode? Regulated diode is also a ordinary diode made of either semiconductor only, normally silicon only, it is available. That is useful for regulating the voltage. That is nothing but a diode which was using a high doping. What for high doping is used is nothing. Every diode in the reverse direction, when you apply a higher voltage, because of the higher voltage, the breakdown, when it exceeds breakdown voltage, larger current will flow and the diode will become short circuited. And once you remove the voltage, even then it will not come back to the original condition. It is not reversible. Breakdown is not reversible in those diodes. But if you opt for a high doping, reversible can be obtained. What is the reversible? You can make the diode to break beyond breakdown potential, but after that, if you remove it again, it may come back to the normal condition. Like that, there are certain diodes, they are called as Zener diodes. Zener diodes are represented by this plus, this minus. This is anode, this cathode. When you apply positive voltage to the cathode and negative voltage to the anode, it starts reverse bias only. In the reverse bias, beyond certain potential, the voltage is going to be constant. The forward characteristics and reverse characteristics can be drawn like this. They are, in the forward characteristics, it works like normal diode only. Cut-in voltage. And the reverse direction, it shows minimum current. After breakdown, it will increase. But the voltage, this potential is constant. This potential is constant. It is broken down, but after that it maintains the voltage. The current may be increasing. When this diode will fail? Only after certain current. When you increase so much, when the current is increasing, beyond this may fail. Therefore, for every Zener diode, there is going to be a regulating voltage as the specification, and also it can be permanently damaged when you are driving more current through that according to the data available by the manufacturer. Therefore, every diode will have a power rating also. You have to say like Zener is, it has got a 6 volt Zener and it has got 1 watt Zener. A Zener may be 0.5 watt Zener. Like that, when you are giving specification for a Zener, you have to say that what is the regulating voltage, what is the power rating. Like that, Zeners are useful for regulating certain things. How Zeners are useful and how they are used as the sensing device for regulation purpose, all these things have been discussed in the regulator video, our video. You can refer to that. And then coming to the varicap diode, varicap diodes means the next diode is varicap diode. For information, every diode has got 2 terminals. In between there is going to be a junction. The junction is a diffusing junction. Because of this, what happens is the glass itself is as a electrostatic material with two electrodes, anode and cathode. They form a capacitance. Every diode has got an internal capacitance. This capacitance is normally small when they are forward biased. This capacitance is going to be large when it is going to be reverse biased. Therefore, according to the distance depletion region, the capacitance can be different. So this characteristics used is made use of in a normal diode for variable capacitance. This capacitance in a variable capacitance diode, varicap diode, when you apply a voltage, this is equal to a capacitance. When you apply reverse bias, that is minus plus, this is going to provide a capacitance. This capacitance is proportional to voltage. Therefore, this diode can be used as a capacitance condenser. This type of condenser is used in several applications in tuning circuits. Tuning circuits. What is the tuning circuit? Tuning circuit is nothing but in communication equipments there have to be oscillators, there have to be circuits which have to be tuned for a particular frequency. Therefore, wherever you have circuits which is working for high frequency, either for generation or for receiving a signal, there are going to be inductors. With inductors, when inductors are coupled with capacitors and the capacitors are varicap diodes, what happens is this LC component can be used for changing the frequency of the oscillator or frequency of the receiving circuits. Therefore, F is nothing but 1 by 2 pi square root of LC. Therefore, when capacitance is increasing or decreasing, F is going to change. So, this type of characteristics of a varicap diode can be used for receiving a particular radio station in a radio receiver or particular TV station in a TV receiver. Like that, you are able to, instead of manually tuning capacitors like that, by adjusting the voltage you will be able to change from one station to another station. This is called varicap tuning. Therefore, varicap diodes are useful in communication equipments maximum. And next diode is switching diode. Switching diode is nothing but when input voltage is suddenly changing from one level to another level in a pulsating DC and other things are pulse generators. When you are moving from one level to another level, a diode has to switch immediately from low level to another level. Therefore, rise time here is going to be minimum. For that rise time in a circuit is nothing but the time taken by the output from moving from 10% to 90%. That is called a rise time. Therefore, this rise time should be small. If it is small, the circuit can be used for many applications. Therefore, in those things, a high switching diode can be useful. That diode is called a switching diode. That has got smaller diffusion capacitance, fast recovery characteristics. Like that, these are very much useful in digital circuits where you want switching from one level to another level, from moving from one level to another level for different applications. They are called as switching diodes. Switching diode, for example, switching diode has a number 1N4148. It's a practical diode. Switching silicon diode is useful for many applications. And then coming to other diode, let me voltage rectified diode. Application is this. Let me explain. You might have operated cathode oscilloscopes. You might have operated television tubes. Cathode oscilloscopes, there are going to be a vacuum tube, big tube with a big screen. There are going to be several anodes, like in between focusing anode and then final anode, like that lot of anodes are there. The final anode in a CRO, it needs 2000 volts. And then in a television receiver, it needs about 20,000 volts or it needs about 16,000 volts for a black and white TV. Like that, there are lot of high voltages necessary to be used in CRTs, either in CRO or in TV, old TVs without not an LED, CRT type of television receivers. Therefore, to develop those voltages, they are using different tactics, because these TVs or CROs are receiving only 230 volts DC, AC only at home or in a laboratory. With that, how can it develop 2000 volts? All these things are possible to generate a high frequency by using different oscillators or transformers. Therefore, when you are having a high voltage alternating current, but if you don't rectify, you cannot apply this voltage to the final anode of the CRT or your picture tube of a television receiver. Therefore, there has to be a diode, rectified diode, which should be able to handle such voltages, and also which should be able to should work under high frequency also. Therefore, in television in black and white, the AC voltage is going to be 15,625 hertz, but the voltage is going to be 20 kV or 16 kV. That has to be rectified. That can be rectified with normal diodes. It cannot be rectified like 1N4002 or any other diode like that, 1N4148. You cannot use it. Those diodes are meant for not even B1 127. There has to be different diodes. The diode has to withstand this much voltage and also fast recovery diode because of the very high frequency. Therefore, what they use is, you're going to use silicon cells. These cells are going to work under low voltage only. Let it be 1000 volts. It will work under 1000 volts only. It may handle high frequency. It may work for 1000 volts only. But we need 20,000 volts. But in that condition, what we can do is, either you can make one diode to rectify this to that. But instead, we can have several diodes in series, and ultimately every diode is working for 1000 volts. 20 diodes can be stacked one over another, like anode to cathode, cathode to anode, like that. We can keep it in series so that 20,000 volts can be rectified to provide 20 kV anode, positive voltage. This can be applied to anode of the CRT in the television screen, either in black and white or in color TV, so that these diodes are very much useful in that. This, for example, the practical diode is called as TV18 or TV20, like that. These diodes are very much useful. They work under high frequency and also high voltage. For example, I am giving all these practical things. Wherever you go, these numbers can be used. And then coming to fuse diode. What is a fuse diode? There are certain applications, please understand, there are certain applications in which you have to apply only maximum 20 volts only. But 20 volts, if the incoming voltage is, maybe if it is less than 20, okay, fine, regulator may handle. Accordingly, the equipment may not be spoiled. But suddenly, because of the spike, because of transients, if the voltage is going very, very high, sensitive equipment, ECG and other things, when you apply a higher voltage, what happens is, that may be spoiling that equipment. Therefore, we have to apply exactly a particular voltage, but there can be a tolerance plus or minus 10%. Beyond that, if there is going to be a spikes in the sense, maybe 1000 volts, maybe 800 volts, like that, it may be going up. When that is going, if the voltage is allowed to pass on to the equipment may be spoiled. Therefore, instead of putting a fuse in series with that, they are going to use a diode as a fuse diode. A fuse diode is applicable and it is connected parallel to the voltage and then fed to equipment. When the voltage is going very high, you can have a resistor here. When it is going very high, what happens is this has a special characteristic such that whatever the voltage is specified for this equipment, this fuse diode is selected. Suppose this is going to be 110 volt. If the diode is meant for 110 volt, until 110 volt, this will not conduct. Beyond 110, it will short circuited. If it is short circuited, this spike may drive a current through the diode, but not to the equipment. Therefore, the equipment may be saved by opting for this type of diodes. That is called fuse diode. Let me come to one more diode, which is called diac. Diac is nothing but, it's a diode used for AC applications only. It's a normal diode only, but it is useful for AC. when you are applying AC, these diodes are going to work under. Diode is nothing but a diode which is useful for AC application only. In AC applications, I have already pointed out, there are certain diodes useful for rectification. There are diodes used for low frequency, diodes for high frequency, and the diodes for regulation. Everything we have used. But this is also like a normal diode only. Advantage is this has a special characteristics in such a way that it will conduct in the forward direction. In the reverse direction, it will have braking potential and all these things it will have. In the forward direction, it will work like a normal diode only. But for this, cut-in voltage is different. Until that voltage, the current is not going to flow. Like that, they are manufacturing diodes not for 0.7. They are going to manufacture this diode for particular voltage. There are diodes available for 32 volt. Therefore, when there is a diode like this, when you apply in alternating voltage, this will conduct only when you get only 32 volts. Beyond which only it will conduct, less than that it will be switched off. Therefore, it is able to output may be like that. Beyond 32 only it will conduct. Less than that it is not going to conduct. The voltage is going to be 0. Therefore, this voltage, the waveform is converted into, like, when you apply 32 only it will conduct. Beyond which it will conduct. Less than that it will not conduct. Like that, there are certain applications in which you have to use diode also. Therefore, I have discussed all the diodes which are ranging from either silicon diode or germanium diode, and applications of rectification, low frequency diode, high frequency diode, regulator diode, varicap diode, switching diode, high voltage rectifier diode, fuse diodes and diode. Like that, there are certain varieties. Still some more diodes are available, but these are all very, very common. It is applicable to all the equipments right now in either in electronic circuits or in communication equipments. Thank you very much for the patient hearing. Thank you.